AI is a crucial component of computer science, and computer science is a problem solving field. There is a distinct life cycle that is used in the problem solving. Thus, the AI also has to follow the AI project life cycle. The AI project life cycle has 5 stages: problem scoping, data acquisition, data exploration, modeling, and evaluation. When we look around us, there is always some kind of issue or hurdle that we tackle. Depending on the nature of the issue, whether they are small or big, some can be overlooked and some cannot be overlooked because it causes impact to us or to the business we are in. The process of identifying the problem and outlining the solution is called problem scoping. In order to identify what the problem is, you can go through the 4 W's, which is called who. Who are the people who are affected by this problem? It could be your stakeholders and customers. Why? Why are we actually trying to solve these problems, and who are going to get benefited by this? Where? Where is this problem occurring? What is the root cause of this problem? And what exactly is the problem? That is the problem identification. Data acquisition, the next stage. The data acquisition has 2 words in it: data and acquisition. Data refers to the raw figures, formats, or statistical information used for data analysis. Now, data can be of various categories. It can be a basic type or a structured type. In the basic type, you have text and numerical data. The numerical data is mostly used for mathematical computation, and it is in the numerical form. It can be like 200 students or 186 bananas. It can be in decimal form as well, like 10.5, 10.6. The text data comprises of textual information. It can be phrases, it can be words. Now, the structured data is categorized as structured, unstructured, and semi-structured. The structured data always has patterns, and it follows a set of rules and constraints, and it has a defined format. For example, the timetable of the school, a table, a tabular column showing the dates, the information of people, or records of the people who are going to come for a game. Unstructured data does not follow any pattern or constraint or any set of rules. They are always unstructured. It can be, for example, we can say the videos which are available on YouTube, they are in unstructured format, or the photos that we upload on the Facebook, they are all unstructured. And semi-structured has data belonging to structured and unstructured format. It contains information which is following a set of rules, and also it contains information that does not follow any rule. Now, in order to get this data, that is, the process is called data acquisition, we need certain sources to acquire this data from. That is called as the data source. There are many different types of data sources you can get the data from. It can be from surveys. Surveys are nothing but a set of information that is gathered from a group of people who are required for a specific purpose. It can be a set of students where you're looking for information to get the tools that they are using. It can be a set of consumers who are using a particular credit card. Those are all survey. Web scraping is a method in which we use technology to scrape the data that is available on the web. It can be the trade information or the stock information or real-time pricing or news. These are all the web scraping information. You can use different type of tools like Python, R languages in order to get this data scraped from the web. When we walk through some door, it automatically opens and the fire alarms gets triggered off as soon as it senses smoke. This all works on sensor, and there is a platform called as IoT, Internet over Things, behind the system of the sensors. So whenever a smoke is detected by this IoT on the sensors, this information triggers the alarm. This is again an information stating that you have to be cautious, there could be a fire. That is an information that the sensors are giving. Next is camera. Whenever we are using a CCTV footage, you can get raw information in the form of photos, videos, clips. That information you can use for further analysis. That is the information from the cameras. Observations. Scientists in the lab uses certain elements to detect under the microscope, like a blood sample, or they introduce certain other biological elements with the blood in order to do their further analysis. This is very time consuming method of getting information, but it is also one of the data source, which is observation. And API is application programming interface. This acts as a messenger between the host and the system. Imagine yourself sitting at a restaurant and you're looking at a menu to order a food item. You do not go directly to the kitchen and order the kitchen staff that you want this particular item from the food. Instead, you will actually use the services provided by the waiter or the waitress who are waiting on you. So the waiter or the waitress becomes the API or the messenger here. They will take the message from you, the host, and go and give it to the system, and the system delivers that services to you through this messenger. That is API. So these are some of the data sources where you can acquire the data from. The next step is data exploration. This is the first stage of the data analysis, where the data is used in order to identify certain patterns and make informed decisions and draw insights from it. There are different tools like data visualization tools in order for you to provide that data in the form of tables, charts, pie charts, graphs, bubble charts, math. The tools which are available can be Excel, Google Charts, Tableau, ClickView, Jupyter, Google Studio, so on and so forth. After you have explored the data and visualized the data, now we come into modeling. Modeling is the process of creating a data algorithm or a data model using an algorithm to identify certain patterns in the data set and predict the future events. Now the AI models can be of two types. One is learning based, another is rule based. Learning based algorithms are the one who self-train themselves. You do not need a developer behind the scene in order to inform the data sets or the data model to provide a set of instructions to them. It self-learns based on the data that is fed into the system. As an example, we can feed data related to the age, gender, location, purchasing history inside an airline system in order to identify the frequent flyer or the passenger information. That is a modeling. In the learning based modeling, there are three categories: supervised, unsupervised, and reinforcement. Supervised is a learning based technique in which a labeled input is fed inside the system to get a prescribed output. As an example, a form which has 4 equal sides is a square. This is the data that is fed inside the system. A square is given as an output or a prediction. In the supervised model, it further gets divided into classified and regression. Classified is a supervised based learning technique which labels the output based on the images that is provided to it. It is the algorithm's job to segregate the information and identify which is true and which is not. So say for example, you are providing a data set or images to the system as apples and oranges, then the algorithm's job is to identify from the images which is apple and which is orange. Regression is a supervised learning model used for continuous used when the data set is in the form of continuous value. Usually this is identified on real-time basis and used for weather forecasting. The next is unsupervised learning based technique. Unsupervised is where the predictions are made by the algorithm based on the independent data set that is generated and given to the system. There are two categories to unsupervised learning, which is clustering and dimensionality reduction. Clustering is a data mining process in which raw objects and unlabeled data is presented to the algorithm, by which the algorithm chooses to categorize them into different categories based on the similarity and differences. There are different methods in clustering like overlapping, probabilistic, hyperbolistic, and exclusive. When the data set has lot of data features and dimension, it becomes increasingly confusing for the algorithm to detect which data is relevant and which is not. At such scenarios, a technique called as dimensionality reduction is introduced. This is a process in which the data input is reduced to a tolerable level, but the data integrity is maintained. Reinforcement is a method of trial and error. It involves an agent who provides the input, which can be either negative or positive, and based on the input provided to the system modifies the environment and either rewards or penalizes the agent. Let's take an example. You want a juice can out of a vending machine. So you introduce some coins inside the vending machine. If the coins introduced is correct, the system informs and modifies the environment and pushes out the juice can to you, which is your reward. Say for example, the coin is damaged or you have not introduced enough coin inside the system. You won't get your output out of this vending machine. This process is called as reinforcement. The next AI modeling is rule-based approach. In a rule-based approach, the algorithm provides the outlined output based on the instructions, set of rules and instructions provided by the developer. There are two sets of data which can be introduced in the rules-based approach. One is a training data set and another is a test data set. The training data set comprises 70% of the data set and is used specifically for training the data model. And the test data set comprises of 20 to 30% of the data set and usually tests the AI model. The last stage in the AI cycle is evaluation. Evaluation is a process of critically evaluating the AI models which has been introduced in the previous stage. We are looking for the performance of the AI model in this particular stage. There are two approaches or basic steps which becomes of essential importance for this evaluation process, which is called reality and prediction. Reality is the real scenario or the real situation, and prediction is the output given by the machine based on the training and testing of the datasets. In order for this to work, you need to collect certain sets of data and obtain an 100% result. Once you have this correct data set with you, the AI model will be introduced with a data set called as reality, and the anticipated results or the output produced based on this reality will be called as prediction. Now let's look at different scenarios in order to understand what is reality and prediction and what is the evaluation method. In the first image, you will see a football with a white and black checkered pattern. In reality, this is a football, and the prediction or the output from your computer is also saying that it's a football. So this becomes your true positive. In the second case, we are introducing a tennis ball. In reality, this is not a football, and the prediction or the output from the system also suggests that this is not a football. So this becomes a true negative. In the third phase, we are introducing a ball which is having a football inside, but from outside is not a football. So in reality, it's not a football, but the prediction is coming out as yes, it's a football. So it becomes a false positive. And in the fourth scenario, we are introducing a football, but we are changing the appearance of the football. Where instead of having a black and white checkered pattern, now the football is being introduced as blue and yellow. In reality, it is a football, but the prediction or the output generated out of the system is coming as no or negative. So it becomes a false negative. So the process of identifying whether a scenario or the given image is in reality a particular football or not is called as confusion matrix. This is a matrix in which the reality and prediction are compared in order to arrive at a particular result. So in the confusion matrix, when the reality is true and the prediction is also true, when the reality and prediction both match, you will get a true positive. When the reality is false, in reality there is no football, but the prediction is coming out to be true, yes, there is positive, then it's a false positive. When the reality is no and the prediction is also no, then it's a true negative. When in reality there is a football but the prediction is coming out to be negative, then it's a false negative. Now, starting a project in the field of artificial intelligence can be very daunting and difficult at the start. But once you understand the phases connected with this AI life cycle, the obstacles and hurdles which you encounter in terms of the infrastructure or data modeling, computation or scarcity or the security will keep fading away, and it will be highly rewarding at the end. Today's session has been inspired by the concepts, images and explanation which is available online on a website called as AI for Kids Official. In CBSE Computer Science, this particular AI life cycle project is taught, and I found it very easy to understand, and that's why I compiled and made this particular course on AI life cycle. Please have a look. Thank you so much for going through this AI life cycle. Stay safe and stay healthy. Bye.